Okay, so far all we've done with these polynomial equations is add, subtract, multiply, and factor. Those are all skills that we need in order to solve equations. So you guys have all solved linear equations before, which is something like 4x plus 3 equals 10, and we're solving for what x can equal. Okay, the difference is here now is if I have a quadratic, which remember is raised to the second power, if I have something of this nature, we can't isolate this x by itself, okay? This x squared and this x. We can't get x by itself. So we can't combine those. So we have to do something else. So what we end up having to do is factor and set this equal to 0 and use what's called the zero product property. So one thing that we need to talk about first before we get started is the difference between standard form and factored form. Okay, standard form of an equation is going to be when you have it in highest exponent to smallest exponent or constant and set equal to 0. Okay, so there is no factors and it is in what kind of we call ax squared plus bx plus c equals 0 form. Factored form is what we've been doing this whole time. Basically, then we're going to set that equal to 0. So here I have this factor times that factor, okay? Notice in here I don't have any factors. So factored form means it needs to be completely factored and set equal to 0. You can't have any addition or subtraction signs between factors, okay? So one thing we're going to do is we are going to use what's called the zero product property, and it's fairly simple. The zero product property basically states that if you have two or more factors and they are set equal to 0, that one or more of those have to be equal to 0. So think about it like this. If I said, hey, some number A times some number B is 0, what are your options? Well, let's just say A is 5. Well, if I plug in 5 for A, then B would have to be 0, right? Or I could have something like, I could say A is 0, and then B could be negative 225, okay? And those would both satisfy that equation, okay? So basically it is when you multiply anything by 0, the whole thing is 0. So therefore, we only need one of the factors to satisfy to equal 0. So if I have something similar to x plus 3 times x minus 5, and I have this equal to 0, I now can say that one of these, let's just pick this one, if I get that whole yellow piece to be 0, then 0 times anything is going to be 0. So it doesn't really matter what this other value for x is. As long as I get one of them to be 0, then it should work for both. So what I can do is I can simply just take x plus 3 and set it equal to 0. When I set that equal to 0, I get negative 3. So I get x to be negative 3. Essentially, if I go and plug that back into that equation, negative 3 plus 3 times negative 3 minus 5, does that equal 0? Well, here, if we see, this does equal 0. And you might say, hey, well, this doesn't equal 0. It equals negative 8. But isn't 0 times negative 8 0? Yes, so negative 3 is a solution, okay? Now, there's also a possibility of another solution. What would be that other solution? Not only can I set x minus 3 equal to 0, but I can also set x minus 5 equal to 0. When I set x minus 5 equal to 0, I get x equals 5. Now let's go see if that works. So if I go plug in 5 for the original problem, I get 5 plus 3 times 5 minus 5. I get 5 plus 3 is 8 here, and I get times 0, which is 0, so it checks out. Okay, so when we have quadratic equations, we actually have the possibility of two solutions. And we do this by setting each factor equal to 0. Okay, and we can only do it when it's equal to 0. For instance, if we look at number 3, it says, which of the following are you able to use the zero product property immediately to solve the problem? Well, let's just say I do this. Let's go and say, okay, yeah, this works. All right, so I'm going to set x minus 5 equal to 5. And I'm going to set x plus 2 equal to 5. And I'm going to solve. When I add 5 here, I get 10. Now, if I plug back in 10, you go, yeah, that works. 10 minus 5 is 5. That works. But we still have to do 10 plus 2. So if 10 minus 5 is 5, 10 plus 2 is 12. Does that equal 5? No, it doesn't. So this can only be done when we have factors and when it's set equal to 0. So we cannot use the zero product property right here because that is not 0. Number 2, I can. Even though I don't have two binomial factors, that's okay. I have a factor times a factor, and it's equal to 0. This is good. Number 1, I don't have a factor times a factor. This is a plus sign in between. I have a term plus some term. That is not going to work. Same thing with number 4. This minus sign is what causes a problem. These are not factors. That would have to be written as x plus 5 times x minus 1. That minus sign in there causes an issue. Number 5, I have a factor times a factor, but it's equal to 1. We can't set it equal to 1, and we can't set it equal to 0. The 1 doesn't just appear, so it has to be equal to 0. Something like number 6 is yes, we have a factor times a factor equal to 0. And number 7 is no. Some of these are solvable, but we can't use that zero product property right away. We have to have factors equal to 0. So we're going to go ahead and just solve some of these problems. So all we're going to do is I'm going to set each piece equal to 0, or each term, I should say. So I have a yellow term and a green term, and I'm going to go set each one equal to 0. So I'm going to set 3x equal to 0, and I'm going to set x minus 4 equal to 0, and I'm going to solve. When I set 3x equal to 0 and I divide by 3, I get 0. When I add 4 on this one, I get 4. Those are my two solutions. You're not going to always have two solutions, but you have the possibility of two solutions when you have a quadratic. So we should always make sure that we have it in factored form. So I'm going to set each term equal to 0. I have a 4, I have an x minus 1, and I have this x plus 3. Now, if I set 4 equal to 0, does that make any sense? Do I have a variable? No. So that 4 is unreducing that quadratic, or is reducing that quadratic. So that 4 has no effect on this answer. Okay. Now, this one did because there was an x. There is no x here. So 4 equal to 0 doesn't make any sense. We're just going to cross that out. But I am going to set x minus 1 equal to 0. And I am going to set x plus 3 equal to 0. When I add the 1 to the other side, I get 1. And when I subtract the 3 to the other side, I get negative 3. So my two solutions for this problem is x equals 1 and x equals negative 3. For number 10, I'm going to set negative 2x equal to 0, and I'm going to set 3x minus 5 equal to 0. When I set negative 2x equal to 0, I get divide by negative 2, and I get x equals 0. 0 divided by anything is 0. On this one, I need to add 5. I get 3x equals 5, and then I need to divide by 3. And we're going to just leave it in fraction form, 5/3. If I write that as a decimal, that would be incorrect because that's going to be a repeating decimal. So it's important to note that it's not just whatever the opposite is of inside the parentheses. You have to set the whole thing equal to 0. So notice this one wasn't 5. It's 5/3. Okay? Number 11, I'm going to set 5 equal to 0, 2x minus 3 equal to 0, and 5x plus 4 equal to 0. 5 equal to 0, 2x minus 3 equals 0, and 5x plus 4 equals 0. 5 equal to 0, there's no variable, so that doesn't make any sense. On number 11, I'm going to add 3 to both sides, and then I'm going to divide by 2. So one answer is 3/2. I'm going to subtract 4. I get 5x equals -4. Divide by 5. I get x equals -4/5. Those are my 2 answers. Number 12, I'm going to set x equal to 0. I'm going to set x plus 7 equal to 0 and x plus 22 equal to 0. When I set x equal to 0, I get 0. X plus 7 equal to 0 and x plus 22 equal to 0. When I subtract 7, I get x equals -7. When I subtract 22, I get x equals -22. So I actually have 3 solutions this time. Well, and that's important to note. This actually, since I have 3 solutions, is actually a cubic and not a quadratic. But I had 3 terms, and I had those 3 variables there. So there's one little piece left, and that's that when we do these problems, the first thing we always need to do is make sure they're set equal to 0. Then we need to make sure that they are in factored form. When I look at 13, 14, 15, and 16, they are not in factored form. So what I need to do is do what we've been doing the last week and a half, is factor these 2 terms. And the way I factor that is I say, ask myself, do I have a greatest common factor? And the answer to that is yes. So I'm going to take out a 4x, and I'm left with x plus 3 equal to 0. Once I am completely factored, I then can set 4x equal to 0 and x plus 3 equal to 0. When I divide by 4, I get x equals 0. When I subtract 3, I get x equals 3. And those are my 2 solutions. Same thing with number 14. I need to ask myself, hey, am I set equal to 0? Yep, check. 2, am I in factored form? I am not. There is no greatest common factor. I know that this has to be 5x and x, and I know that this has to be 1 and 1. I also know, because this is a +1 and a -6, that has to be subtraction inside. Let's just go double check. I get -5x, -1x. Yes, that gives me -6x. So there's that yellow and that green. Those are my 2 factors. I'm going to set them equal to 0. 5x minus 1 equals 0. And x minus 1 equals 0. And I'm going to solve. I get 5x equals 1. Divide by 5, I get 1/5 as one of my answers. And when I add 1 over, I get x equals +1 as one of my answers. 2 more. Number 15, it is set equal to 0. And now I have a GCF. I'm going to take out a 3. After I take out that 3, I need to attempt to factor that. I'm going to use 4 and 3, because then the insides would give me 4x and the outside would give me 3x, which would add to 7. I'm going to set each term equal to 0. When I set each term equal to 0, I get 3 equals 0, x plus 4 equals 0, and x plus 3 equals 0. This is not a variable, does not exist. I'm going to subtract 4 and I get -4. I'm going to subtract 3 and I'm going to get -3. Number 16, I do not have a GCF, but I am set equal to 0. So I'm going to attempt to go like this. I know that then that bx term needs to be 0. So I know that 1 has to be plus and 1 has to be minus. These are what is, again, called conjugates of each other. Very, very similar, just the middle sign is different. I'm going to set each of them equal to 0. And when I set each of them equal to 0, I add 1. I get 3x equals 1. And therefore, I get x to be 1/3. And over here, I'm going to get x to be -1/3.